Let me pull it up real quick.
All right. We are live.
All right. Question number 3. Okay, I'll start with question number 3. What requirements must be checked when conducting a hypothesis test comparing two means with independent samples? So we need a simple random sample drawn from each population, as well as the mean being normally distributed for each group. So just the first and second one there.
2. Yep, that's what I got. All right, question 4. The test statistic for a hypothesis test comparing two means with independent samples is a t-score.
All right, number 5 is two samples are independent if knowing which subjects will be in group 1 tells you nothing about which subjects will be in group 2. This is the second one.
Yep.
There.
All right. So, inputting all the information on the dentist office bills, using the less than null hypothesis, and a level of significance of 0.10, the degrees of freedom was, I got 37.996.
Yep, that's what I got.
Okay.
Let's see here. Number 7, what's the standard sample deviation for Rexburg? So that would just be the second variable. Standard deviation was 206.637.
Yep, that's what I got. All right, the test statistic. Now, didn't I say that a test statistic? Well, no, that's not right. So I got negative 0.434.
Yep, that's what I got.
Okay, that's right.
Yeah, it's just the t-score.
Yeah.
Right. What's the p-value? The p-value is 0.333.
Yep. All right. And then, so we fail to reject the null hypothesis because the p-value is greater than?
Greater than the level of significance. Number 11, suppose instead that you had used the alternative hypothesis that the means were not equal. What's the correct decision based on this evidence? So we're trying to find, we're trying to say that they are different, but since we fail to reject the null hypothesis, we have insufficient evidence that the mean dentist bills between the two cities are different, which would be the second one there.
Yep. That's what I got. All right, for the next 6 questions, use the data. So it says in the question, so what is the appropriate alternative hypothesis? And it says, we're trying to figure out, so it says, you suspect that freshmen from Utah cooked dinner themselves a different number of times. So when it says different, that means it's just not equal to. So it would be the second one.
Yep, that's what I got too. The test statistic, t-score, is negative 0.845.
Why would I've got positive on here?
Possibly one thing that they kind of changed on us was in the Excel sheet. We were supposed to do Colorado. It says, where was it? Use. Let the new one. So variable 1 should be Colorado, and variable 2 is Utah, and so they were kind of switched.
Okay.
So that might have been.
Well, hold on. Now I'm looking at my. Now I'm looking at my data, like my Excel,
Mm-hmm.
and I have 0.845. So I don't know where I got negative.
It's supposed to. No, it is negative.
I mean, I don't have negative.
Right. Wait.
So I need to switch them around. So I didn't do that.
Yeah. So variable 1 starts with 13. Should be for the Colorado.
Okay.
Differences, and then variable 2 should be Utah. Should have 12 samples. Variable 1 only has 10. I kind of suspected that they would pull something like that on us.
Yeah.
Make it a little more difficult.
So do I just switch the variables, or do I switch the data over?
I would just switch the data.
Okay. Let me just switch it real quick and see what.
Yeah, because I think some of the functions are based on those variables.
Okay, that's right. Now I have negative 0.845.
Okay. Cool.
Kind of mess me up. All right. Okay. So then the p-value, number 14, the p-value would be so it's 0.411.
Yep.
All right.
And since the p-value is greater than the level of confidence, we would fail to reject the null hypothesis for number 15.
Nope. All right. So I didn't quite understand this 16. Like, I know when you take don't you take the upper bound and the lower bound and divide them or something like that? Is that
So
right?
what I did was, so it's wanting to know the difference between the two means. So I just took the two means, the 15.2 and 16.667, and I subtracted those. That gives you negative 1.467. And then my thinking was for the top interval, it equals that negative 1.467 plus the margin of error. So we don't know the margin of error yet. So I did negative 1.467 plus x equals, and that would give us the top interval, or the top confidence interval, so 2.214. So then you just solve for x by adding 1.467 to 2.214. And it actually gives you, that one gives you 3.681. And then to go the other way, to solve for the low one, you would do, I think you subtract. How did I do that one?
So you got 3.671.
No, it's sorry, did I say 3.6? It's 3.681.
Okay.
Yeah. And then if you plug that in, if you went back to the negative 1.467 and you subtracted 3.681, it would give you the low confidence interval. It would give you negative 5.147. And then if you add 3.681 to negative 1.467, it would give you the high confidence interval.
Okay.
You can kind of test them there.
Oh, okay.
Mm-hmm. Does that
All
make
right.
sense?
Yeah.
Okay, cool. So then 16 is 3.681. And then the last two are pretty easy. They're pretty much given.
Yeah. And they're just on those are just the lower and upper bound, right?
Uh-huh. Yeah, so 17 would be negative 5.147. And the upper bound would be 214. That's it.
All right. Easy enough. Cell makes it a little easier for sure.
Yeah, definitely. Yeah, I know. I was like, that one was pretty easy. I mean, it's funny because it's like they want us to get like the overall concepts
Uh-huh.
of the the hypothesis tests, but kind of the meat of it is pretty complex
Mm-hmm.
if we were to do all the different equations. So they just give us the software, which I appreciate.
Yeah, I know. I'm not gonna complain.
Right?
So. All right, man. Well, cool.
All right.
Easy enough. See you on Monday.
See you on Monday.
All right, bud. Take it easy.
Bye.